You're paying for a VPN service every month. Here's how to run your own instead, for free, faster than most commercial options, and you're the one who controls the exit node. That last part matters more than people think. When you use a commercial VPN, you're routing every bit of your traffic through someone else's servers, trusting a company you've never met, not to log it, sell it, or hand it over. When you self-host, that third party simply doesn't exist. Your traffic goes from your device back to your own home network and out to the internet from your own connection, meaning any site you visit sees your home IP, not some rotating address in a data center you've never seen. You've already seen the commercial side of this on the channel in the Best VPNs for Privacy video, where I tested a handful of paid providers head-to-head. This video is the other half of that conversation. What happens when you skip the provider entirely and run the tunnel yourself? The trade-off is real, so let's be honest about it up front. A self-hosted VPN depends on your home connection being up when you need it, and your exit node is your own IP address, not a rotating pool across a dozen countries. If your goal is geo-unblocking streaming libraries, a commercial VPN still wins that specific job. If your goal is securely reaching your own network and your own traffic from anywhere, self-hosting wins outright, and it costs nothing ongoing. We're building this on WireGuard specifically, not OpenVPN, not IPsec. WireGuard is a modern VPN protocol built from a fraction of the code those older protocols carry, which means fewer places for bugs to hide and meaningfully faster throughput on the same hardware. It's become the default choice for exactly this kind of home setup for good reason. There are two solid paths to get WireGuard running, and which one you pick depends on what hardware you're already running. If you're on UniFi gear from the earlier videos in this series, WireGuard is built directly into your gateway already, no extra hardware needed. If you're not, a Raspberry Pi or your NAS running a lightweight tool called WG Easy gets you there just as reliably. Let's start with UniFi, since a lot of you are already on a UCG Max. Open the UniFi Network app, go to Settings, then VPN, then the VPN Server tab, and click Create New. Choose WireGuard as the connection type, and give it a name you'll recognize later. Once the server's created, go to Clients and add one client per device you want connected, your phone, your laptop. Each gets its own separate configuration. UniFi generates a QR code for each client automatically, so on mobile you just open the WireGuard app and scan it directly. No manual typing of keys required. If you're going the Raspberry Pi or NAS route instead, WG Easy is the tool I'd point you to. It runs in a single Docker container, gives you a clean web dashboard for managing clients, and generates the same kind of scannable QR configs UniFi does, just self-hosted entirely on hardware you own outright. One gotcha that trips people up on either path. Most home internet connections have a dynamic IP address, meaning it can change without warning, and if it does, your client configs suddenly point at an address that no longer exists. Set up a free dynamic DNS service and point your WireGuard endpoint at that hostname instead of a raw IP, so the connection keeps working automatically even after your ISP reassigns you a new address. Either way, install the official WireGuard app on whatever you're connecting from, phone or laptop, and either scan the QR code or import the config file directly. Test it on your phone's cellular connection specifically, not your home Wi-Fi, so you're actually verifying the tunnel works from the outside, not just proving your local network can talk to itself. While you're setting up each client, decide on full tunnel versus split tunnel. Full tunnel routes all of that device's traffic through your home connection, which is what you want for public Wi-Fi at a coffee shop or airport. Split tunnel only routes traffic destined for your home network, leaving everything else on the device's normal connection, which is faster day to day if all you need is access back to your files and cameras. Now, the security basics, because this is exactly where people get sloppy and undo everything they gained. First, port forwarding. WireGuard needs one UDP port open, 51820 by default, forwarded from your router to whichever device is running the server. Forward exactly that one port to exactly that one device, nothing broader and nothing else. This is precisely the kind of narrow, deliberate port forward. The Firewall rules video was about one specific service, one specific destination, Everything else stays closed. A WireGuard port sitting open is low risk on its own, since the protocol doesn't respond at all to unauthenticated traffic, but low risk only holds if you haven't also left other ports open alongside it out of habit. Second, keep your keys private, always. Every WireGuard client config contains a private key that's functionally equivalent to a password, and unlike a password, you generally don't rotate it casually. Don't screenshot a config file and text it to yourself. Don't paste one into a chat app. And if you ever need to revoke access for a specific device, delete that client entirely and issue a fresh one rather than trying to reuse it. Third, and this one gets overlooked constantly, never expose your router or NAS admin panel to the internet, even though you're now comfortable poking around in it to set all this up. If remote management is enabled on that admin interface, turn it off or lock it down to VPN-only access, meaning you can only reach it after you've already connected through the tunnel you just built. If you followed the VLAN segmentation video earlier in this series, one more refinement worth making. Put your VPN server on a network segment that only has access to what you actually need remotely, not blanket access to every device on your LAN by default. That way, a compromised phone connecting in doesn't automatically get a clear line to everything else you own. Here's your actual checklist. WireGuard server running on either your UniFi gateway or a Pi with WG Easy Dynamic DNS pointed at your endpoint. One client config per device with full or split tunnel chosen deliberately. Exactly one UDP port forwarded and nothing more. Keys treated like passwords, and admin panels locked to VPN-only access. That's a complete, working setup. No subscription, no third party in the middle, and genuinely better throughput than most of what you were paying for. This is exactly why we built firewall rules and VLANs first in this series. Self-hosting a VPN on a network with no segmentation and no rules is handing yourself remote access into a house with no locks. On a network that's already hardened, this is the piece that makes anywhere actually mean anywhere, safely. You've now got a fully closed loop, locked down with firewall rules, segmented with VLANs, monitored for anything unusual, and reachable from wherever you are without paying anyone else for the privilege. If you want the deeper comparison of what you're giving up and gaining by skipping a commercial provider entirely, check out today's short, VPN service versus self-hosted, which actually protects you. Subscribe if you want the rest of this home network hardening series, no fluff, just what to actually build. From firewall rules to VLANs to this, you've now got a home network most small businesses would be lucky to have. Thanks for watching. Stay secure out there.